This conference will now be recorded.
Dear students, good evening. Now we are going to start in our session on KVPY-SA 2011 questions in continuation of what we have done in the earlier classes. So the point is, see, I got a query from one of the students. Let me quickly reply. I think there are questions. I am getting few questions from our group. So you remember that I gave hints to question number uh, 14 of part 1 KVPY SA 2011. That is the mathematics question. The question is, a certain 12-hour digital clock displays the hour and the minute of a day. Due to a defect in the clock, whenever the digit 1 is supposed to be displayed, it displays 7. Okay. What fraction of the day will the clock show the correct time? You can think this question as a question of probability as well. Hmm? So the question could be reframed as that: what is the probability that it is showing a correct time in the entire day? So to proceed this question, I can give you multiple solutions to this question. Okay, so let us discuss one by one. So this clock, we consider a 12-hour digital clock. How we can? So method one, I'm going to solve multiple ways. The first one is that method one. Okay. So we can consider the 12-hour digital clock displays the hour and the minute a day in this format. We can write it that X, Y, Z. If you look into this one, it looks like that X is the hour representation, Y and Z together is the minute representation. Now, if this is the case, then X can take any natural number from, X can take any natural number from 1 to 12. From 1 to 12. So this is one point. I hope you got it, because it is the hour and it both from 1 to 12 in the daytime and in the night time. So it can take values from 1 to 12, which is 12 in numbers. Then what is the value Y can take? That Y can take any integer from 0 to 5. Y can take any integer from 0 to 5. 0 to 5, which are 6 numbers. So this is how many in number? This is 12 in numbers. 0 to 5, these are 6 in numbers. Then it is coming the third one, Z. Z can take values from 0 to 9. Z can take any integer any integer from 0 to 9, which are 10 in numbers. So the total number of ways that XYZ sequence can happen. So the total number of ways. So the total number of ways. Total number of ways that XYZ sequence can happen is, it is 12 into 6 into 10, and 12 into 6 into 10, that is equal to 720 ways. Now let's see, these are the total number of ways that XYZ can occur ideally, but there is a malfunction. What is the malfunctioning? Whenever it is supposed to show 1, it is showing 7. So due to this, there is a defect, and this defect in this clock, then what are the values of X can take for the correct timing? So when it will show the correct timing, okay, so what is the correct timing? Correct timing is that correct timing for X and Y and Z, that we are going to find it out. So due to this malfunction, the correct timing for X can happen, X can take the values from which list? X can take the values from the list 2, 3, 4, 5, 6, 7, 8, and 9, which is 18 numbers. These are the correct values it can take. Now, what are the values of Y it can take? Y can take the values, for correct timing, it can take the values 0, 2, 3, 4, and 5. And these are 5 in numbers. And what are the values Z can take? Z can take the values, 0 to, let me write it down, 0, 2, 3, 4, 5, 6, 7, 8, 9. And these are 9 in numbers. So we see, despite having the defect in the digit 1 in the digital clock, the total number of ways XYZ sequence can happen. Okay. So due to this defect, correct timing, due to this, despite this defect, despite the defect, okay, the correct sequence for correct timings is what? Is are possible in, so I can write in, are possible in 8 into 5 into 9 ways. 8 into 5 into 9 ways, okay, that is equal to what? That is equal to 360 ways. Okay, sorry. So what is the required fraction then? The required fraction of the day will the clock show the correct timing. So required fraction is what? So we get the required fraction as a required fraction we are going to get is equal to 360 by 720, which is equal to 1 by 2. So here required fraction means what? Here is the required fraction of the day that will ensure that clock shows the correct time, which is 360 by 720 equal to 1 by 2, and we get the correct option as option A. Now let me show you some another method. Okay, so we can solve this problem in multiple methods. Let me show you another method. Let me use a different color pen. So here I'm going to show you in the blue color the method 2. Any doubt, please, never hesitate to raise your question. In method 2, what I would like to, view the problem in completely different manner. Here, here is my thought process. The clock will display the incorrect time in our hand whenever 1 appears in the digital clock. Quite obvious, because that is what is mentioned in the question. That when there is 1 is appearing as 7. So the clock will display the incorrect time in our hand whenever 1 appears in the digital clock for the entire hours of. So what are the possible cases then? It can happen for 1, it can happen for 10, it can happen for 11, it can happen for 12. So, and these 1, 10, 11 and 12, these are the hour hand, and that it can happen for both day and night, day plus night. Okay, and as it is happening for both day and night, then what is the total hours? 8 hours, correct? This is for 1, it is 1 hour, 10, it is 1 hour, 11 is 1 hour, 12 is 1 hour, both day and night. So it becomes the 8 hours. Now out of these 24 hours, that 8 hours, it will, show the wrong time due to the hour hand. So that means it will show the correct timing for the 16 hours, correct? So as we see, if I write, here is that out of 24 hours, out of 24 hours, 8 hours will show, 8 hours will show a wrong time, due to our clock. Okay, so that implies what? 18 hours, sorry, 16 hours. 16 hours means what? That is equal to 24 minus 8. 16 hours, it will show correct timing. And then what is the required fraction here? So which is equal to, 16 by 24 is equal to, 2 by 3. That is the, fraction. Now, that means in 1 hour, 2 by 3 fraction, it will show the correct timing due to the hour hand. Now let's come to the hour clock or hour hand, the way you want to define, because here it is a digital clock, there is no hand by the way. Now, out of this 23 fraction, there is a minute, clock is also contributing wrong timing. How the minute clock is contributing the wrong timing? Let's find it out. Here also you can assume the digital clock is something like that X, Y, Z. If I write it here in the, here, so if you see the digital clock is something like that X, Y, Z, then we just found it out that X can happen for that 1, 10, 11, 12, that we already found it out. Now for Y and Z, how it can happen? You see the Y and Z, how it can malfunction. It can malfunction when it having a combination like having one at it, one, in it, 10, 12, sorry, 10, 11 is also there, 11, 12. In that way, it will go till 19, 10, 11, 12, 13, 14, up to that 19. These are 10 in numbers. And it can also happen 0, 1, 21, 31. In that way, it will go till 51. It cannot go to 61 because it will go to the next hour then. So how many numbers are there? 0, 2, 3, 4, 5, which is actually in 5 in numbers. So that means what we see is that out of that 1 hour, that means in 60 minutes, 10 plus 5, 15 minutes, it will show the wrong timing in every hour. Correct? So what we see? So this implies what? This implies in each hour. So in each hour, that means it is in 60 minutes. So here is here there is a relevance that why 60 minutes I am writing. In each hour, that is in 60 minutes, 10 plus 5, that is 10 plus 5, that is 15 minutes. That is 15 minutes will show wrong time, will show a wrong time. So that implies what fraction it will show the correct time. So this implies 1 minus 15 by 60 fraction, it will show the correct timing. It will show correct timing. Okay. Now, what does it mean? It means is that 1 minus 15 by 16 means 1 minus, 1 minus 15 by 16 is coming to 3 by 4. So 3 by 4, 3 by 4 fraction, okay, it will show correct timing. So now for this 2 by 3 fraction, whatever I wrote here, out of this 2 by 3 fraction, 3 by 4, it will show the correct timing. So the required fraction will be what? So required fraction in this case, a required fraction is equal to 2 by 3 into 3 by 4, because out of this 2 by 3 fraction, which is correct due to the hour clock, minute clock will be correct 3 by 4. So here is the principle of multiplication, that is 2 by 3 into 3 by 4, which is equal to 2 by 4, which is turned out to be 1 by 2. So you see that by means of two different methods, we reach to the same conclusion of the answer, and we get the correct answer as 1 by 2. So if you have any doubt, please do let me know before we proceed to the next question.
Sir, I have a doubt.
Yeah, please.
Sir, in the first method, I didn't understand why we multiply 12, 6, and 10 to get the number of ways.
In the method 1 or method 2?
Method 1.
Achha. Let me explain you. Your name, please.
Shreya.
Okay, hi Shreya. So if I understand your question, could you please repeat once more, if you never mind?
Yeah, sure. In the first method, I didn't understand why we multiply 12, 6, and 10 to get 720.
Oh,
The
okay,
number of
okay,
ways.
okay. I do understand your question. Thank you very much. See, think about a digital clock which is there in your home. It will show something like this, na? XYZ. That you agree?
Yeah.
isn't it? It will show something like XYZ,
Hmm.
where X is the, our representation. And how X will vary? X will vary from 1, 2, 3, 4, like that. Na? Every hour it will change. At, midnight it will be 12. Immediately
Hmm.
after midnight, after 1 hour, it will be 1, 2, 3, 4, up to 11. And again it will come to 12 and 1, correct?
Yeah.
So X can take any natural number from 1 to 12. That you agree to me?
Hmm.
Okay. Now, y is what? Y is an integer from 0 to 5, isn't it? Why it is 0 to 5? Because you think about, visualize the digital clock, what is there in your home. If you
It's,
see the y cannot be 6, isn't it?
yeah.
Because it is after 59 second, it will not go to 60 second. It will increase the hour by 1, and
Yeah, I got.
minute will come to 00, isn't it? So y
Hmm.
can take the value from 0 to 5, isn't it? So
Hmm.
how many numbers are there from 0 to 5? Integer values 6, isn't it?
Yeah.
Okay. And for z, it can take the integer from 0 to 9, because it can have 59 second, 49 second, till 9 it can go.
Hmm.
Now think about the sequence. For any value of x, suppose you consider x is equal to 3, then y can have any value 0 to 5.
Yeah.
And for that value of y, any value from 0 to 5, z can have any value from 0 to 9,
Hmm.
isn't it? And here comes the, if you are done with permutation and combination, there is something called principle of multiplication. That means for each occurrence of x, I can have each 12 occurrence of x, precisely to say, there are 6 occurrence of y it can happen. And for
Hmm.
each, so that means in how many ways x and y can be actually come together? 12 into 6 ways, isn't it?
Yeah.
And for each of these 12 into 6 ways of occurrence of x and y, z can occur in 10 ways.
Hmm.
So principle of multiplication, the total number of ways, the sequence. That's why I wrote this word called sequence, x, y, z sequence.
Hmm.
The total number of ways the XYZ sequence can happen is 12 into 6 into 10. That is 720.
Yeah.
Is it absolutely clear?
Yes, sir.
Good. And in if you are done with permutation and combination by this time, there is something called principle of addition and principle of multiplication that ensures, by looking into a problem, first you need to understand whether I need to take the addition or multiplication, or combination of both, depending on the context of the question. Anyway, shall I proceed to the next question?
Sir, there's similar doubt in the method too. I didn't
Oh,
understand why you multiplied 2 by 3 and
okay,
what is
sure.
the next?
Okay, all right. I'll explain you. I do understand your question. So you see, now method two is I'm looking into in a completely different manner. Think about the hour hand here. If I represent, let me use a different color. Hmm, Just give me a moment. Uh, if you look at here, the here also the same digital clock representation x, then yz. You see that x can get wrong by for what values? X can get wrong for any of these values.
Yeah, I got that.
Hour is 1 or 10 or 11 or 12. It can get wrong, and it can happen both day and night. That
Hmm.
means total 8 hours it will show wrong time due to the hour clock, isn't it?
Hmm.
So that means due to the hour clock, it will show correct time 24 minus 8 hours, isn't it?
Yeah.
And 24 minus 8 is 16. That means out of 24 hours in a day and night, due to this malfunctioning of the one, it will show the correct timing 16 hours. So what is the fraction? 16 by 24.
Hmm.
So 16 by 24 is 2 by 3. So 2 by 3 is what? It is the fraction of an hour. That means in you take any hour, the 2 by 3 is the probability that it will show the right time. If I give the flavor of probability a little bit here, that means out of any hour, 2 by 3 hours, it will show correct time due to the hour clock. Correct. Now our clock is fine, but then we are also, there are two other clocks are there. 2 hour means Y and Z, that is for the minute. Correct or not?
Yeah, sorry, the internet connection went bad for a moment.
Now is it clear?
Yeah, it's clear.
Okay, so now for each of these 2 by 3 fraction, Y and Z can also get wrong. How Y can get wrong? Y can get wrong if it gets the value, sorry, Y and Z together can get wrong if it takes the value 10, 11, 12 till dot 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 up to 19. Or it can have 0, 1, 2, 1, 3, 1, 4, 1 and 5, 1. If it take 10, 11, 12 up to 19, these are 10 in numbers. And if it takes 0, 1, 2, 1, 3, 1, 4, 1 and 5, 1, these are 5 in numbers. Correct?
Yeah.
Now, so then total how many minutes it can get wrong? It can get wrong total 10 plus 5, 15 minutes. Within that hour is what? Hour is 60 minutes.
Yeah.
So within that 60 minutes, 15 minutes can get wrong. That means what fraction it will get right? 1 minus 15 by 60? 1 minus 15 by 60 is 3 by 4. So 3 by 4, it will get correct for each hour. Correct? And each hour in the entire 24 hours, what is the fraction that it will show the correct timing due to hour? It is 2 by 3 hours. And out of these 2 by 3 hours, 3 by 4 hours is actually correct timing due to the minute clock. Correct? So then here also principle of multiplication 2 by 3 into 3 by 4. Correct?
Yeah.
So by the way, method 2 is a little complex with respect to method 1, but still I discuss because all these are very important when we will be discussing probability in future. Okay, very important because you always need to look into the problems into multiple viewpoints, multiple ways. That will make your idea very clear. Anyway, if you agree, then can I proceed to the next question?
Yes, sir. Thank you very much.
Okay, all right. So let me proceed to the next question. If you look into the next question, and that also I gave little hints in the in the last class. There are 30 questions in a multiple choice test. A student gets 1 mark for each unattempted question, 0 mark for each wrong answer, and 4 marks for each correct answer. A student answered X question correctly and scored 60. Okay. Then the number of possible values of X, that means how many ways he can write the correct answers to get the score 60. Is the question clear? Okay, in case any one of you tried in the last since our last class, you can you can message me in that in our chat box that if you get an answer. Yes, Rest, I thank you very much for your answer, but I'll let me not reveal. I will explain it. Thanks, Rest. Yeah. Anyone else? Okay, so let's see how we can approach this problem. This is a straightforward question, not that challenging with respect to the previous one. You see, unattempted, unattempted, if we write here unattempted. Yeah, Pratik, let's see. Shreya, Pratik, thank you very much for your answer, but let me solve it. Let me not reveal it at this moment. So unattempted, here it is. How many marks unattempted? 1 mark. Then it is wrong, means if the answer is wrong, then it is 0 mark. And if it is correct, then you will get it is 4 marks. Now let's see the first choice, how it can happen. It can be 0 unattempted, 0 wrong, and 15 correct, because 15 into 4, that is 60. Clear? So another choice could be 4 unattempted, 0 wrong answer, and correct answer is 14. Then also you'll get what? 4 into 1 plus 14 into 4. So in this case, what it was? 0 into 1 plus 15 into 4. That becomes 60. Here, what you get? 4 into 1 plus 14 into 4. That will also get 60. All these values will give you 60. Then it can be 8 and it could be 0 and it could be 13. And if you see 8 into 1 plus 13 into 4, that will also give you 60. Then it can happen 12 unattempted, 0 wrong, and 12 correct. Then what it will be? 12 into 1 plus 12 into 4. That will also give you 60. Then it may possible 16, then 0 wrong, and 11 correct. So that becomes 16 into 1 plus 11 into 4. That will also give 60. Then we can have 20 unattempted, 0 wrong, and 10 correct. So that means 20 into 1 plus 10 into 4. That will also give 60. Apart from this 6, it is not possible to find any other options, any other choices. Okay, so 6 is the correct answer. Option C is the correct, because if you find any other choices apart from these 6, please do let me know. So these are the 6 choices. That means according to the question, the student can take either 15 correct answer, means 15 questions with correct answer 15 or 14 or 13 or 12 or 11 or 10. Less than 10, it is not possible, and more than 15, that is also not possible. So that's why 6 is the correct answer. In case of any doubt, please do let me know so that I can explain before I proceed to the next question, which is from physics.
Sir, why can't you take less than 10?
Okay, tell me a number less than 10.
So now if you continue the same sequence, you get 24, 0, 9.
24,
0 and 9.
24, 0 and 9. So
24
then
into 1
24 plus 36.
is 60.
Yeah. Just a minute. Yeah, I think you are correct.
And the sequence continues until...
Okay, no, just a minute. 24 plus 9 is actually going beyond 30, right? That's why it is not.
No, it's coming exact 60.
No, there are 30 questions in a multiple choice test.
Oh.
If you answer 24 and 9, then it cannot be, it adds up to more than 30, na? Do you agree to me?
Yes, sir.
Yeah. So that's why it is not possible to have 24 and and 9. It is not possible. Okay. Any doubt? Any further doubt before we proceed to the next question?
Sir, I have a doubt.
Yeah, please.
Sir, how do we know that there's no combination involving more than 0 wrong answers?
Yeah, you tell me a number, na? That is all by inspection. You can think of, yeah, you are correct, but subject to the condition that you need to give an option. You tell me that how it is possible to have, non-zero wrong answer and the other combination. Tell me a combination, then you can investigate. The way Pratik said one combination which violates the condition that the number of questions should be within 30, right? See why it is so. Generic point I can say is that whatever the wrong answer you attempt, it contributes to the value 0. Correct? Irrespective of the number of wrong answers you give, it is 0. Then it has to be balanced to number 60 has to be balanced by the either by unattempted or by correct. So that's why these are the combinations. Suppose if you make it more than 15, then how much will be your unattempted? It has to be 0. As unattempted has to be 0 for 15 correct questions, then we cannot go beyond any other question which is wrong, isn't it?
Yes,
Similarly,
sir.
it cannot go below 10, right? So who asked this question? I think it is Prahlad.
Yes, sir.
Okay, so is your query clarified? Did you get your answer?
Yes, sir. It's clear.
Okay, good. Now let's proceed to the next part of that is called the physics. Okay, so let me bring the
Sir,
physics question. Yep.
sir, can we also have 15 right answers and 15 wrong answers and 0 unattempted?
Okay, now if you take 50 correct answer, very good. Who is you? Who is the person?
Sir Vaishnavi.
Okay, great, Vaishnavi. I appreciate your, that sequence what you said, but that is actually being covered with respect to the question. If you give 15 correct answer and 15 wrong and 0 unattempted, you are correct. Then what happens? But what is the question? Question is that a student answered X question correctly. Then what are the possible values of X? So in the combination of 0 unattempted, 0 wrong and 15 correct, X is 15. And if you write 15 unattempted, 0 wrong, 0 wrong, 15 unattempted and 15 correct, then also X is 15. Isn't
Yes,
it,
sir.
Vaishnavi?
Yes, sir.
Yeah, but I appreciate the sequence you said. The sequence is valid, but this is already been taken care by the other sequence called 0015.
Thank
Clear?
you, sir.
Okay,
Yes,
great.
sir.
Okay, so let me proceed to the next question. I really appreciate the way you are asking questions, and you can ask any time also, in any of the previous question. So look into this question. The first one is that, you see, a simple pendulum oscillates freely between the point A and B. We now put a nail at the point C as shown. As the pendulum moves from A to the right, the string will bend at C, definitely. Okay, and the pendulum will go to its extreme point D. Okay, so the pendulum will go to its extreme point D, and you ignore the friction where the point D will be. Okay, so this is a very classical question based on the laws of conservation of mechanical energy. So what we can say is that you know if you see the kinetic energy plus potential energy, uh, yeah, Pratik, let's see how it will happen. Let me solve it. By mechanical energy conservation, what we get is that kinetic energy at the initial point plus potential energy at the initial point should be equal to kinetic energy at the final point plus potential energy at the final point. So this implies what? This implies kinetic energy should be 0 initial point, obviously, and plus, Uy should be equal to because in the two extreme points, the kinetic energy should be 0 because there is no motion there. So 0 plus you will get UF. So what it is ensuring that Uy is equal to UF. And we know the mass is constant, G is constant. So height of the initial one should be equal to the height of the final one. So the extreme point D will lie on AB and we get the correct option as A. So extreme point D will lie on AB, right? Because the height has to be same. I hope this is straightforward and clear. So we can proceed to the next question. Okay, so if we go to the next question, it says, a small child tries to move a large rubber toy placed on the ground. The toy does not move but gets deformed. That is very important. It is not getting moved and it is getting deformed. So does not move is a very important statement in this context to the question, but gets deformed under her pushing force F, which is obliquely upward as shown. It is shown. Okay. Now out of these four options, which one is going to be correct? Since toy is not moving, there is no acceleration on the toy, correct? So acceleration on the toy is 0. Acceleration on the toy is equal to 0. Now, so the resultant of all the external forces, what are the external forces? So the resultant of all the external forces, resultant of all the external forces, what are those external forces? The first force is, the pushing force. Then what is the second force according to the question? Second force is the weight of the toy. Then third one is the normal force by the ground on the toy. Obviously, so that is the normal force. Normal force by the ground on the toy. And the last force, which is the frictional force. And the frictional force. If you see all these four forces, if you add up of all these four forces, that is going to be 0. That's why that acceleration is 0. Toy is not moving, that means acceleration on the toy is 0. Acceleration is 0 from the Newton's second law of motion. It tells that the force must be 0 because mass into acceleration is equal to the force. As mass acceleration is 0 and mass is not equal to 0, so mass into acceleration is obviously 0. That means force is equal to 0. We know very fundamental from the Newton's second law of motion. Force is equal to mass into acceleration. Now as mass is not equal to 0, acceleration is 0, so m into 0, that is equal to 0. So what we can conclude? We conclude that now the resultant of the pushing force, weight of the toy normal force by the ground on the toy and the frictional force, their resultant, means their algebraic sum is going to be 0, and we get the correct option as A. This question on the fundamentals. Okay, now let's go to a next question. Very classical questions from kinematics. Okay.
So just a second, discuss the other options too.
Which option you think of?
No, like I just discuss why the other options are not compared to A.
Fine. Shall we proceed to the next question? Okay, let me proceed to the next question. The next question, it tells that a juggler tosses a ball up in the air with initial speed u. At the instant it reaches its maximum height h, he tosses up a second ball with the same initial speed, which is u, obviously. The two balls will collide at a height that we need to find it out. So let us first visualize this problem. Okay. So if we visualize very clearly, so let's go through the statement and let me draw the diagram. So suppose this is the ground, or let me draw it here. Suppose this is the ground, and first the juggler throws a ball and it reaches to the height, this height. Suppose this is the point A from where he throws, then it reaches the point B. Let's assume this is a straight line. So let me draw it properly. So this height is actually capital H according to the question. Maximum height is H. So this height we are getting is actually capital H with the initial speed u. Then we will use the formulas to get that when it reaches to the point B. The moment, if you see the second one, at the instant it reaches to the maximum height h. Okay, so first ball has been thrown from here. That is, the first ball has been thrown. Once it reaches to the maximum point B, another ball is actually thrown from the same ground, and the second ball is thrown. Then what happens is that the moment the first ball is actually about to fall, at that moment the second ball is actually thrown. Then they will meet someplace, and suppose we assume they will meet at the point C, and which is the height at a height h, lowercase h from the ground. Then according to the question, we need to find the value of lowercase of h in terms of capital H. As simple as that. That means what? At this point, if you look into this point, this plane actually where it is meeting, so h is the height from here, from the ground. So obviously from the top point, it will be capital H minus h. So this is first the visual representation of the problem, and after that we are going to solve it the way we want. Clear, I hope. Now let's synthesize the statement. The first ball will cover the path BC when it is actually it will, let us assume it will take t time after the second ball is thrown from the ground. So then in that t time, what will happen? So we are assuming that when the second ball is thrown, after that t time, it will need to have both the balls to collide at the point C. Okay, so then what are going to happen in this case? The first ball will cover the path BC, the first ball will cover the path BC, that is the distance capital H minus h in time t. So what I am writing, the first ball, so let me write it here, let it will take time t after the second ball is thrown from the ground. Thrown from the ground. Then there are two cases happens. What is the first case? First case is that the first ball will cover the distance BC. So it will cover this distance BC, isn't it? At what time? It will take that distance BC at the time t. And what is the initial velocity? Initial velocity is 0 because it is having a free fall from the point B. So, and what is the BC distance? BC distance is h minus capital H minus small h. So you can use the formula h is equal to ut plus half g t square. Ut is what? 0 into t because initial velocity is 0 plus half g t square. So what it gives, this will give us an equation called capital H minus h is equal to half g t square. So we give this equation as equation number 1. Now let's study the second ball. What the second ball will do, second ball will cover the distance AC. Okay, that is the distance AC is nothing but the lowercase h at the same time t, starting from the point A with an initial velocity u. And there will be, the formula what we can use is that lowercase h is equal to ut minus half gt square, because distance will get distance will go up, but there is a retardation because it is go against the gravitational force. So 1 by 2 g t square. This is the second equation we get. And another equation we also get is that we can use the v square. What is the velocity v? Final velocity will be 0. So 0 square v square is equal to u square minus 2 into g into capital H, obviously, because once it is started, the first ball is started from the point A. Once it reaches to the point B, the velocity was 0. That is actually coming from the first ball, by the way. So this is the equation number 3. So how many unknowns we have? We have, if we study these 3 equations, we have unknown lowercase h that we need to find it out, and there are another unknown, that is t, time parameter t, and there is one known parameter, that is u, but it is not there in any of the options. So in this context to the question, this u is also unknown. So we need to resolve this u and t by means of these 3 equations that we can easily do, because number of unknowns is less than the number of equations, that we can do it very easily. But let's see how we can do it. And you can do it in multiple ways. So what is the target? Target is to find the value of lowercase h as a function of capital H. So if I write in a very mathematical description, what you need to do, you need to find the value of h as a function of capital H. That is your task. So what we are going to do is that if we add the both sides of the equation 1 and 2, if we add both sides of the equation 1 and 2, what we'll get? We will get capital H minus h, capital H minus h. Yeah, you can use Pratik. Yes, there are multiple ways you can. Absolutely, you can use this thing. But this is the simplest method. That is equal to, half of gt square plus ut minus half of gt square. So if you simplify further, then we'll get this, we'll get capital H is equal to U into T. And there is a good things we get, because both the unknowns U and T are expressed by means of a known quantity capital H. Now let us find the how we can derive the value of H from the above equation 2. So from the equation 2, what we get? From the equation 2, we get the value of H is equal to U into T. So let me write first. It is U into T minus half into G into T square. Okay. So that is equal to what? U into T is equal to capital H, as we already found it out. And then we get half, as we write half into G. G, let it be there, and T square. What is T square? T square we can find it out from the equation 3. That is, you get, if you look into this equation 3, from third equation we get what? G into T square. T is equal to U square into, T square is equal to H square by U square from the equation 4, this one. So from this one, what we get? So this implies, T is equal to capital H by U. So this will be capital H square by U square. Now what is the value of U square? Let's find the value of U square. U square is equal to 2GH from the equation 3. So from here we can write that U square is equal to 2 into G into H, 2 into G into capital H. 2 into G into capital H. So let us apply this value. So it is capital H minus half into G into, I'm sorry, just a minute, give me a minute. The digital pen is little malfunctioning. Half into G into H square divided by U square. U square is what? 2GH. 2 into G into capital H. And if you simplify further, you will get the value of H minus H by 4, because GG got cancelled, 1H and H square got cancelled. So that is equal to 3H by 4. So that is equal to, so this implies we get the value of H is equal to 3H by 4, and we get the option C as the correct option. Very classical question. I hope you have done this kind of problem while discussing motion in a straight line. Okay, so let's proceed to the next question. If you have any doubt in this question, please do let me know. Otherwise, let us proceed to the next question. Next question is that, on a horizontal frictionless frozen lake, a girl of 36 kg and a box 9 kg are connected to each other by means of a rope. Okay, initially they are 20 meters apart. So that means if we visualize this problem, then how we can write it down? If we consider, this is the girl, okay, and if you say this is the girl here, okay, and it is at a distance of, there is a box here, and the box is 9 kg, and the girl is 36 kg. Okay, now you see that this distance between them is 20 meters. Okay, That is the visual representation by looking into the first statement. First two statement. The girl exerts a horizontal force on the box, pulling it towards her. How far has the girl traveled when she meets the box? So that means what happened? So after that, let's assume the distance traveled is x. So now the girl is here. Okay. And box is also near to her. Sorry, what happened? Just a minute. Give me a minute. Okay, so anyway, I do not know how I lost this thing. So let me redraw. So this is the girl initially. Okay, so 36 kg. And then what happened is that the girl, and the box are nearby. And the girl has moved at a distance. Let's assume the distance, x. We need to find this value of x, by the way. Then the moment this has been traversed x, then the box has been traversed 20 minus x, obviously, because the distance between them was, okay, 20. Now, these are the pictorial description of the statement. Now there is no external force working on the system. There is no external force working on the system. So according to the concept of center of mass, what we get is that the 36 into x is equal to 9 into 20 minus x, correct? Because that is, we are actually understanding from the center of mass. This implies what? This implies 45x is equal to 180, and we get the value of x is equal to 4. And we derive the girl will travel a distance of 4 meters when she meets the box, and we get the correct option as D. Okay, I hope this is a very straightforward question from the center of mass.
What is the center of mass thingy?
Okay,
Like
so okay, great question. So your question is, what is center of mass? Yeah. So I can give you an example. Center of mass is something where we can assume that if we make a translatory motion, then there will be as if the mass is concentrated on that particular position, it will have the same translatory motion. I can explain you better by means of an example. Think about there is a hammer. You know the hammer, so let me use a different color to explain this.
Sir, actually, I understood. It's fine. I got it.
Okay, great. Then fine. Okay, so then I can proceed to the next question. But there is a fundamental difference also. Let me tell you. I can ask each one of you, what is the difference between center of mass and center of gravity? Do you believe there is a difference between center of mass and center of gravity? If so, what is, and if not, what is not? I mean, why it is not? And what is the difference then? Either you can express your answer by talking, or you can write in the chat box. I will give you 30 seconds to answer that one before I proceed to the next question. Because understanding the difference between these two will help you to understand exactly what is center of mass and eventually what is center of gravity. So, there is difference, Pratik. There is difference. What is center of mass? Center of mass, as I said, is that, if I give you a little example, let me give you a quick example. It will not take much time. And it is also important to know these fundamentals. Think about there is a hammer. Okay. And in that hammer, so generally what you see, this portion is made out of wood, and this portion is actually made out of, iron or some metal. Now, what do you believe the center of mass could be? Where it could be center of mass? The center of mass, your common sense is telling the center of mass will be somewhere here, isn't it? Why? Because if we give a force like this, or if we give a force like this, which is in line to the going to the center of mass, it will make that hammer to have a translatory motion. Okay, translatory motion happens to a system of particle. That means what? All the particles in that body will have a same displacement with respect to the same time. That is why this point is the center of mass. But we cannot consider this point as a center of mass. Why? Because if you give a force something like, if you give a force something like that, it will not have any translatory motion to the hammer. It will have a rotational motion to the hammer. So that is why it cannot be a center of mass, whereas it is a center of mass. Now, what is center of gravity? Center of gravity is nothing but the resultant of the gravitational force of all the points of the object. So generally there is no difference between center of mass and center of gravity. But if you think about some large objects like Mount Everest, center of mass and center of gravity are two different points. In fact, the center of gravity of Mount Everest is little lower point with respect to the ground, little lower than the center of mass. Why? Because if you consider this is the Mount Everest, okay. So what happened is that at each point, if this is a rigid body, so anyway, we can discuss, have a later some class to describe about the rigid body and not rigid body. So at each point there is a gravitational force of attraction towards the center of the earth for each of these point. Now these are the different forces, and you can make these are the forces on that particle. It's called the gravitational force. Now as it is, there are multiple forces from the vector concept, so we can have a resultant force. And the resultant force, the point of the resultant force is known as the center of gravity. Now we know that center of gravitational force is actually increased towards the center of the earth. So for a particle in the top of that Mount Everest, the amount of gravitational force will be lesser than a particle here in the bottom. So as a result, what happens is that if you make a resultant of all these forces, you will get center of mass could be some point here, whereas center of gravity could be in this point here, where that is called, you can call it CG, but whereas center of mass could be a point something somewhere here. Because center of mass doesn't depend on any force, there is no, it doesn't depend on any parameter which is variable. Means here center of gravity depends on a parameter which is variable, and what is the parameter? Is a force which is variable. Force is not fixed because of the, here the force is center of gravity, gravitational force of attraction. But center of mass, whether it is the top of that Mount Everest or at the bottom of the Mount Everest, okay, everywhere the mass is same. So that's why center of mass is actually a constant one. And the center of gravity can also change over a period of time, as the height of the Mount Everest is also changing. So anyway, these are the fundamental difference between center of mass and center of gravity. Anyway, let's proceed to the next question. And next question is question 20. If you look into the next question, so there are three objects: a metal tray, a block of wood, and a woolen cap are left in a closed room overnight. Next day, the temperature of each is recorded as T1, T2, and T3 respectively. So, what could be the likely situation? Is it all the temperature are going to be equal? T1 is equal to T2 equal to T3, or T3 is greater than T2 greater than T1, or T3 is equal to T2 but it is greater than T1, or T3 is greater than T2 which is equal to T1. So, the answer to this question is that all the three will be in thermal equilibrium with air of room. So temperature of all the three will be same, and the correct answer is A. But not by only giving the answer, I would like to go little forward to this one. It is called the 0th law of thermodynamics. Now it is observed that a higher temperature object which is in contact with a lower temperature object will transfer heat to the lower temperature object. The objects will approach the same temperature, and in the absence of loss to their objects, loss to the other objects, they will then maintain a constant temperature. They are then said to be in thermal equilibrium. That is the essence of thermal equilibrium. And thermal equilibrium is the subject of the 0th law of thermodynamics. So we get the correct option A, and we can proceed to the next question, which is question 21. Okay. So question 21 is also based on the fundamental understanding, and here is the question is: we sit in the room with windows open, then option A, air pressure on the floor of the room equals to the atmospheric pressure, but the air pressure on the ceiling is negligible. Option B, air pressure is nearly the same on the room and the walls and the ceiling. Option C, air pressure on the floor equals to the weight of the air column inside the room from floor to ceiling per unit area. And option D, air pressure on the walls is 0 since the weight of the air acts downward. So the pressure of gas is same everywhere in the, we get. So then we get the correct option as B, that air pressure is nearly the same on the floor, the walls, and the ceiling. Okay, this is a very straightforward question. Now let's proceed to the next question, which is question 22. And this is a very good question. I like this question, by the way. If you read to this thing, you will also like. It looks like a question of, motion in a straight line or kinematics, but it is not. A girl standing at point P on a beach wishes to reach a point Q in the sea as quickly as possible. That is very important statement, as quickly as possible. She can run at 6 km per hour on the beach and swim at 4 km per hour in the sea. Which path she should take? There are 4 paths you see. One is PAQ, second one is PBQ, third one is PCQ, and the fourth one is PDQ. I start getting answer from you. I appreciate, but let me explain that what could be the right answer. So think about the velocities. In in beach, velocity is higher, and in the sea, the velocity is less. So that means what? The beach where the velocity is higher becomes a rarer medium, and the sea where the velocity is less, it becomes a denser medium. So then what we can visualize? We can actually visualize a case something like this, that if this is the separator between the beach and the sea, so if it goes like this, then it has a tendency to bend towards the normal. So this is sea and this is beach. So now what happens is that, so when the girl goes from the rarer to the denser medium, it bends towards the normal to reach in the minimum time. That's why the light travels. And we get the correct option as C, PCQ, but not D. D is also tending towards the normal, but it actually crosses the normal. So because it crosses the normal should be somewhere here. It crosses the normal, so that's why it cannot be the PDQ. So PCQ is the right option. Okay, so now let's go to the next question. Okay, now next question is question 23. Is that light enters an isosceles right triangular prism at normal incidence through the face AB and undergoes total internal reflection at face BC, as shown below. As you see, then it is actually going to the AB, and from here, from BC, it is actually coming with a total internal reflection. So the minimum value of the refractive index of the prism is what that we are going to find. Now, if you recall the concept of total internal reflection and critical angle, we know one thing. If critical angle is the angle of incident for which the angle of reflection is 90 degree, that is called the critical angle. So if we assume that IC is the critical angle, then we know this formula IC, sine of IC is equal to N2 by N1. What is N2? N2 and N1, N1 and N2 be the refractive index of the prism and the air respectively. Okay, so N1 is for the prism and N2 is for the air respectively. Now for air we know it is 1, and what is the from the diagram it is very clear that critical angle is 45 degree. So we need to find, we know the value of N2 is 1. So now it is just to find the value of N1. It's pretty simple. Apply the value, then we'll get sine 45 degree is equal to 1 by N1. So from here we get N1 is equal to 1 by sine 45 degree, and that is nothing but from here we get n1 is equal to root 2, and we know the from the given options, in context to the given options, we can consider the value of n1 is equal to 1.42. So this is the minimum value it can happen, and we get the correct option as C. Okay, so I hope all of you understood this question. Now we can proceed to the next question, which is question 24, and here it is. A convex lens is used to, okay, Shrestha, you asked the critical angle. So, it is also a topic of, class 10, if you studied, that light reflection and reflection. So, the critical angle, the angle of incident beyond which rays of light passing through a denser medium of the surface to the less dense medium, no longer refracted but totally reflected. Okay, so how it happens, it is, I can keep on explaining this thing. So let me give you by means of an example. So think about why this diamond actually glitters that much. Okay, and if you see a broken glass, if you see through the broken glass portion, you will see this is actually, the more light is coming from there. It is all due to, the concept of total internal reflection. So let me explain you by means of an example. Okay, and it will be very clear to you. So think about, this is a denser medium. Below is the denser medium, and and in this is the lighter medium. So suppose let's consider this as air, and we consider this as suppose water. Okay, then water is a denser medium. Then what will happen, that you consider the, this is the normal. Suppose a incident rate goes like this, it will refracted like this, isn't it? That is the way it happens. Then again you give a incident ray, so it will be refracted like this. So that means you increase the, incident ray, the angle of incident, you will find that angle of refraction is also happening like this thing. Sorry, it will be 3 only. Then let me use a different color. So then what happened is that you make that incident ray in such a manner, okay, so that the angle of, refraction is become a 90 degree. That becomes 90 degree. Okay. Okay. You got the point. So then this angle is known as the critical angle. This angle is known as the critical angle. Now, why it is critical angle? Because if you make any, angle of incident more than that, so let me use a different color again. Suppose let me use this color. So if you make an incident ray beyond this, what will happen? That complete ray will reflected back into the same medium. It will not, there will be no refraction. It will be reflection. So that's why, that is why it is called total internal reflection. Is it clear? Critical angle. So in fact, we can have some class later, to explain you about that, light reflection, refraction, and prism, lens, both, and the mirror, convex mirror, concave mirror, convex lens, and concave lens. Okay, thank you, Shrestha, for your confirmation that you understood. Now let's go to the next question. So that is going to be the last question of our session today. So the question here is, if you read through, that in a convex lens, convex lens is used to form an image of an object on a screen, that we all know. If the upper half of the lens is blackened, so it becomes an opaque, then what will happen? What is going to happen? Option A, only half of the image will be visible. Option B, the image position shifts towards the lens. Option C, the image position shifts away from the lens. And option D, the brightness of the image reduces. Which is going to be the correct one? So if you look into um, the way the convex lens works, is that if I draw, so it is something like this. So if you consider this as a convex lens, so what happens is that the rays from the object, suppose this is the object, so from the object rays goes, and it actually goes like this, okay, and from here again it goes like this, sorry, it goes like, sorry, it goes like this, then in like this thing it goes like this. In that way it happens, okay. So it can happen from here also. After that it goes like this, and you get the image here. So this becomes the image location, that is the image location. And where is the eyes? So these are the locations where our eyes are. So this is the eye, okay. So these are the locations of our eyes. So that is a very simple diagram to explain that how image formation happens in a converging lens. Now if the upper half portion of the lens is blackened, it will be blocking half the rays incident on it. So the image will be formed by the rays of the bottom half of the rays, and it will be half as bright of the original one. So we conclude the brightness of the image will reduce, and the correct option we get as the option D. So fine. So with this, I would like to conclude today's session. I hope it was informative. This session was informative to you. See, one very important point I would like to mention, that we do not have much time. We have this month is very critical. So whatever the solutions myself and my faculty members discussed with you, we took sufficient time to explain the concepts. And the reason behind explaining all these things is that you can process and solve similar problems. And now what is my plan moving forward is that I would like to send you the solutions to the questions upfront, okay, for all these years, 2011, 12, 13, 14, 15, 16 till 17. And you go through all these solutions, detailed solutions at your end, and get back to me in any questions, so that our faculty member can be in touch with you for any doubt. Because if we discuss in the same page, it will take more time to complete. But this is also important. We should not go in a very hurried manner, then our basic understanding will not be clear. So we need to make a proper um, mm, balancing between these two. So what I'll do is that in another 1 week or so, you will start getting all the detailed solution, okay, and you look into those solutions. Wherever you have doubt, get back to us and we'll be in touch. So with this, I am done with the topic what we are going to discuss today. We had a plan to discuss today. Now if you have any question, please do let me know uh, before we actually close the session for today. Thank you very much, Shreya. Thank you, Akanksha. Thank you, Pallavi. Thank you very much. Thank you, Vaishnavi. Thank you, Anaga. Thank you, Pratik. Thank you, Shrest. Thank you very much.